upthrust. So now let us discuss about pressure in fluids. So pressure in fluids, okay. The substances which can flow easily are called as fluids. So examples are liquids and gases, because liquids and gases can flow easily. So we are going to see the pressure inside the fluid. Like solid, like liquid, like gas, we have pressure in liquids as well, that is a fluid, okay. But a fluid, liquid or gas exerts pressure in all direction, like sideward, downward and even upwards, okay. So now let us take an example to understand all the things about the buoyancy. So buoyancy is nothing but an upward force exerted by the object onto the liquid, that is called as buoyancy. So to understand the concept of buoyancy, let us take a beaker. Okay, let us take a beaker which is filled with water. In that water, we are just going to place a mug. Okay, I'm going to just dip the mug in the beaker. So when you give force onto the mug goes down, and when you release the hand, the mug comes up. Why it is coming up? What makes the mug comes up? So some force is upward force is acting on the a liquid onto the object. That force is called as buoyancy. So when the object is placed in a liquid, the liquid exerts an upward force on it. This force is called as buoyancy. It is easy to lift a stone as long as it is inside water, but it feels heavy when it is lifted above water, correct? No? A mug of water inside the water appears lighter, but it feels heavier when it's lifted above the water. Therefore, the object appear to be less heavy when submerged in liquid than they are in air. This shows every liquid exerts an upward force on the object immersed in it. The tendency of a liquid to exert an upward force on the object placed on it is called as buoyancy. This upward force is otherwise called as upthrust or buoyant force. Cause of buoyant force. What is the cause? So when a mug is inside the water, the pressure from the sides are equal and no net force is available. But the pressure at the bottom of the mug is more due to the depth of water, and it is less at the top. So the difference in pressure causes the net upward force called buoyant force. The mug, usually made of plastic lighter in water, is pushed up due to upthrust. So when you place iron nail and plastic, so the iron nail will sink and the mug will float because of the density. Yes, no, the density of iron nail is more than the density of water, so the iron nail sinks, and the density of plastic is less than the density of the water, so the iron nail, so the plastic floats. Okay, so let us have a picture, that is experiment to study about the buoyant force. We are having a spring balance, we are having a weight, okay, weight of the body in air is measured as 60 and 60 Newton, and weight of the body partially immersed in liquid is 50 Newton. Partially immersed in a liquid is 50 Newton. Weight of the body fully immersed is just 40 Newton. Okay, so this is the best example that we have given for buoyancy. And factors affecting the buoyant force. So what are the factors that affects the buoyant force? One is volume of the object, another one is density of the object. Okay, as the volume of the solid immersed inside the liquid increases, the upthrust also increases. So volume is directly proportional to buoyant force. Volume is directly proportional to buoyant force. Buoyant force is directly proportional to density. If the density increases, buoyant force also increases. If the density decreases, buoyant force also decreases. So next comes Archimedes Principle. So in Archimedes Principle, when an object is wholly I'll tell the principle first. When an object is wholly or partially immersed in a liquid, it experiences an upward force that is equal to the weight of the fluid displaced by the object. So buoyant force is also called as upthrust, acting on the object, is equal to weight of object displaced by it. So next comes application of Archimedes Principle. Archimedes Principle is used in determining the relative density of a substance. Okay, The hydrometers used for determining the density of liquids are based on Archimedes principle. The lactometers also, okay, it is used to measure the purity